And I want to share my desktop. So let's first talk about the testing process. So you might want to jot down that the comprehensive final is Tuesday, 12:15. You have 2 hours, up to 2 hours to take the comprehensive final. You can choose which time in this window that you want to take the comprehensive final. I will talk about the strategy that you should use, in which order you want to do what in terms of this process. So let's talk about this in an organized way. And I'm going to use my bullets that I used to create the video last night. What I would recommend doing first is to reread all testing announcements in Canvas. This is very, very, very important. Testing violations are, this summer, at the end of the summer, 10 o'clock the night before grades were due, I was reviewing a video and noticed a student left the testing environment. So I contacted our department, one of our department chairs, co-chairs, and she said to give her a 0 for the final because she left the testing environment. She not only left the testing environment, she came back with what looked to be a phone in one hand and a wad of paper in the other. So I'm just saying this to you because those pre-steps before the test are just as important as the test itself, because you can lose points on those pre-steps. And, you know, our department co-chairs are going to support us, has proven by the what happened this summer. So you don't want to lose those points. So you want to take your time with those steps before. And you want to know what all the violations are. I don't even know what's in all those testing announcements. And I wrote them at the beginning of the semester because there's so much detail in them. So it's important that you look those over. Even if you've looked them over before, it's really important to look them over. I want to see all of you do very well on the test, which is why I'm taking some time here to go over this with you. So let's go into Canvas and look at some of these announcements. One in particular. Let's look at one of these announcements. I think I've got it right up here. So this is our course, and you will see, just to point this out, the syllabus is here. Feel free to look at that. This quiz, actually our instructional designer at NWAC, who helps people set up Canvas the way that works for them, he said to use a quiz for the assessment questions. So you'll see quizzes here. That's where you're going to go to take your assessment questions, or and they are multiple choice. Multiple choice questions are sometimes a blessing and sometimes a curse, because if you do a problem like you're used to doing the problem, you may get the correct answer, but you don't have it in the form of one of the multiple choice answers. So just keep that in mind. Modules is where you're going to go to upload your written work. I'm trying to keep the process as much the same as possible, so that it's very familiar to you all. Modules is where you're going to go to upload your written work. Announcements, you definitely want to review those announcements. And then the grades. That's where I go to grade your written work. Everything has a score of 0 in Canvas, just so it's not confusing to you all. your grades are kept in the instructor grade book in ALEKS. The instructor grade book matches the grade book in ALEKS. I cannot see your assignment scores in ALEKS. I have no record of them in my ALEKS software. So I know I've been working with a student or two, and I think that student may not understand that you just go to the gradebook. That's where the scores that I see are kept. So I wanted to remind you all of that. So if you have a grade discrepancy or something, please let me know, but make sure you're going to the gradebook and looking at the gradebook score and not assignment scores. So let's take a look. I want to first talk about this announcement, and this is one of the testing announcements. I'm going to click on announcements, and this is the student view, this view that you see. You'll see there are quite a few announcements about testing. How to get a clear picture of your government ID, how to take my exam test. This one just applies to test 1, so proctored testing violations, that applies now. So this one applies now, this one applies now, this one applies now, this one applies now, this one applies now. Where to go for help? I welcome your questions. I can try to help you with any questions you have over the weekend as much as possible, as much as our schedules permit, if you need help. And so there are quite a few announcements here, and they're quite detailed. I want to talk about one only in particular because we have other items that we need to talk about today in our class to finish everything up and not have any loose ends. I want to talk about this announcement. How to get a clear picture of your government-issued photo ID in order to avoid a testing violation. I have 6 classes and 120 plus students, so I won't be able to go into Canvas and try to look at student IDs and match the ID on the driver's license with the ID on that was presented right before you took your test. I don't have time to do that, unfortunately, because I have to turn your grades in really quick, and I've got to vet your grades in the sense that I've got to calculate some of the students' grades to make sure the software is working like it's supposed to. Sometimes it hasn't in the past, and I will be honest with you, it doesn't always work perfectly. So, and I'm a perfectionist, so I need to check all of that. So I have a lot to do. So this is extremely important. And I only have your best interests at heart. Every testing center in this country that you will go to take a test in will ask you for a government-issued photo ID. They will not let you take the test otherwise. And they may have your best interests at heart, but we need, in order to give a student a score on an exam, we need to know you are who you say you are right before the moment before you take the test. And I don't have the luxury of knowing you all like I would in a classroom if I had you for all semester in my classroom at NWAC. I don't know you really. I know very few of you because of the nature of remote classes. I wish I knew you, but I don't. So we need to take a look at this. This is about test 1. No violations were given because it was a learning experience. It is your responsibility to read and thoroughly understand all Canvas announcements and all emails sent by Ann Bear, as well as read and understand the syllabus. Points will be deducted from test 2, test 3, and the comprehensive final for any testing violations. I encourage you to take your time with all the steps immediately before the test, reading and understanding all information on the screen as you go. I have seen some students in the video rushing through the steps before the test. You really want to take your time with these steps too, because they can mean that you get points subtracted, which is not a good thing. So please take your time with all the steps. Presenting a clear picture of your government-issued photo ID is a key step in this process. That's because every testing center in the country, or in the world really, any reputable one, requires you to present a government-issued photo ID. And because you're using your cameras on your computers to take a picture, they don't know the difference between a government-issued photo ID and another picture of yourself. They don't. And none of the software knows the difference because of that. So the software isn't robust enough to identify the difference. So we just have to work with it because it's the best option that we have. The math department could have students use live proctoring, which costs like 5-6 times as much. And you don't want that either. So it's just something we all have to live with, which is why I took hours to create this announcement at the beginning of the semester. Let me make sure. So you are required to take a picture in which I can clearly read both your first and last names. There may be a delay in your camera taking a picture, and that's because you're using a webcam in part. There is a delay. There's a delay with almost all cameras, really. You can take as many pictures of your government-issued photo ID as needed to get a clear picture of both your first and last name. I really need to see the first and last name. For each picture you take on the left side, you can check it on the right side for readability before proceeding. So I created this, and it took a long time because I had to deal with the lockdown browser and all of that and get very creative. I had a lighting issue, which is why I had to put a Post-it note over this side. So there's two screens, really. There's a screen on this side that looks like looks like this screen did before the ID was presented. There's a screen on this side and a screen on this side. So you take your picture of your government-issued photo ID on this side, and then you can check it to see if you can read it on this side. And since you're showing your student photo, taking a current photo of yourself in step 5, you do not need to show your current photo or take a picture involving you currently. You just need a picture of your ID. So you can fill up the space with your ID. So I took a picture of my mom's ID on this side, and I checked it on this side. I did use a bit of an angle here so that I found that helped me be able to read the ID better. And I can read her ID, Nancy Ann Rudolph. So this is my mom. She passed away in late July of this year due to natural causes. She was in her 80s, so she was getting up there. So what happens if this is blurry? You can go here to try again. You can retake the picture. It's circled in yellow here. You can retake the picture. Then you check it. Can you read it now? If you can't read it, you take it again. I literally took a picture 7 times, and they still I did not reach their endpoint in terms of how many times I could take a picture. So you can click on try again as many times as needed to get a clear picture. So keep trying until I can clearly read your first and last name. You definitely want to avoid a violation. So let's go back up here. You can take as many pictures as needed to get a clear picture of both your first and last name. And I would like to see the picture of you on that ID too, like I see the picture of my mom right there. I didn't want to use my current driver's license for obvious reasons, because my information, that's my personal information. So for each picture you take on the left side, you can check it on the right side for readability before proceeding. We talked about how to take another picture. Not getting a clear picture of your government issued photo ID is a testing violation. If for some reason you cannot comply with getting a clear picture of your government issued photo ID with both your face and your first and last name, stop and contact me. Do not take the test. Do not start the test. There's no reason that you would have to start the test. You're still not in the test, so you can still call me on your phone. You can go into Microsoft Teams and call me, and I will get a message on my phone immediately, and I can talk to you via Microsoft Teams if I need to. It's very important, because if there really is an error, which there could be, I haven't seen one yet though. If there really is an error, then it may be affecting many of my students. I've got 2 ALEKS classes, my online anytime testing on Monday and Tuesday, and 2 additional ones testing on Tuesday, my 2 remote ones. So I have a lot of students testing. If there's an issue, I need to know about it. So if you go through this process and you don't contact me, if you go through this process and you have a problem with your ID and you don't contact me, that definitely will be a testing violation. I will have the attendance for every student in this class today, so it's important to take your time with each step. Any questions on this announcement? So there's one more announcement I'd like to take a look at here. And I'm trying to remember exactly which one it is. I think it might be uploading written work to Canvas. Nope, that is not it. Let me just, I want to really find this one, because I think this is very, very important. Now that I'm thinking about it, very, very important. How do I take my exam or test? The second one. Yes, this is extremely important. This one, you're allowed to have by your side when you take your comprehensive final. It leads you through all the steps. Open the Chrome browser and so forth. And even to this level of detail, you will not need to pay $10. That was a one-time fee. But there's really very little mention, if any, of the lockdown browser. And I do know that some students have been telling me they have lockdown browser problems, and I just send them this document and they figure it out. So please just be aware of this document. You can have this by your side. You can either copy it down, you can print it off. However you can want to get this document, I would encourage you to have this by your side when you take the comprehensive final. Any questions so far? That was just the bullet, reread all testing announcements in Canvas. So what I would recommend is that you reread all testing announcements in Canvas on Monday evening, including copying this one down or printing it off so that you know all the violations, you understand how everything works together and so forth. Then on Tuesday, when you go to take to complete the final exam process, how do you do that? I would recommend that you go into ALEKS first. You're used to doing that. Go to ALEKS and take the ALEKS final. So the ALEKS final is just like your first 3 exams. It's as similar to your first 3 exams as I could make it. That is, the written work required questions will be the first 7 questions. Unfortunately, I cannot give you the written work required topics ahead of time. That would be violating math department policy. I can't do it for the final. But you still will have those 7, the first 7 questions will be written work required. The last 10 questions will be, you will get the score that ALEKS gives you, just like before. You will have up to 2 hours, just like before for the ALEKS portion. Any questions on that part of it? So going into ALEKS, the first thing on Tuesday when you want to go through the testing process, you will have those steps, those pre-steps that you're going to take your time with, and then you will take the test just like you're used to. And then everything will work pretty much, I mean, it's going to work the same, except that you won't know what the written work required topics are. But what you will know, let's go into ALEKS here, but what you will know is, let me see, I think I've got an ALEKS, yep. Let's go into ALEKS here. I'll pick your class, 12009. See where you got down here at the bottom. And let's go into Class Tools, Student View. Enter Student View. So what you will know, that you see this final exam review part 1 for 5% course credit. There's also final exam review part 2 for 5% bonus. This is worth like 30 points of your course grade if you want to look at it from a points perspective. As is this one. Those two together are worth like 60 points of your course grade. Lots of points. So what I want to say is every question on the ALEKS only portion of the comprehensive final is going to come from one of these 2 assignments right here. And there's about an even split base. About half of them come from this assignment and about half of them come from this assignment. So it's important to do both. And also, in the ones that you think are more complex, a good place to look for written work questions may be the written work required questions from before. That's a place to look. Not to say that all of them will be written work required questions that you had before, but that's a place to look. You're looking for the questions that are going to take where you really do usually need to write out some written work anyway. So you've got all of this right here. And I don't know if I've got the exact time on them. I have, for some reason, 3:30. I'm probably just going to leave it as 3:30 here. I need to change it to match what I had said before. I will change it to match what I said before, which is 10 a.m. to 3 p.m. But if it's going to benefit you, then I'm going to let it benefit you. So I'm going to change this one to 10 a.m., but you'll still have until 3:30 p.m. So I need to change that, and I will. I haven't gotten quite that far. Any questions on this? I wanted to show you what we're looking at here. And your matrices homework, which we are going to talk about today, finish up, is due tomorrow night at 11:59 p.m. So now let's say you finished your ALEKS test, you've got your written work written down for the first 7 questions. That would be makes sense to go into Canvas because you only have 15 minutes to upload your written work. So then you go to Canvas. Remember, if you're looking at the Canvas announcements the night before, on Tuesday, you just go into ALEKS first, and then you go into Canvas. So that seems pretty self-explanatory, right? So let's go back into Canvas now and take a look. So I'm still in the student view. Let me just remind you where you go to upload your written work. You go to modules, click on modules, and then scroll down, upload final exam written work here. And then after you've uploaded your written work, you then want to go take this quiz. It's probably not going to appear here, and it won't because I have not made it available yet. So that part of it, I'm going to show to you, some of it to you, by going into my own Canvas account. Let me leave the student view. I want you to see what that looks like. I'm back in my account. If I now go and click on quizzes, you can see what you will then be looking for is this fall 2020 college algebra assessment questions. There are 4 questions. They are multiple choice. This is not a practice quiz. It's only set up that way so that there's 0 points in Canvas because all of my grades are kept in ALEKS. It will be worth points. It's not going to be worth a lot of points because there are only 4 questions compared to 17 in ALEKS. So any questions on that process? So I think I try to keep it as self-explanatory as possible. When I was first thinking about it, I'm thinking, oh, I've got to do all of this. And it's because there's no way for me to enter my own or the department's questions. They use a different software because most of the college algebra instructors, except for me, teach with a different software. But I started teaching with ALEKS a few years ago, and I've had success with it, so they let me teach with ALEKS. But I have to make some adaptations. And I've been working with the ALEKS folks. They wanted my input yesterday, and they offered to give me an honorarium, and I did talk about the ability for ALEKS to allow us to type in our own questions. Any questions so far? So let's talk about a couple of test-related items, and then we'll talk about working with matrices. This is the window, but I'm going to extend it, I believe, for your class to it's going to be 3:30 because I just saw that in ALEKS, and I'm going to then give you also, I need to make it start at 10 a.m. for you. So I will honor that, and I've got a note to myself right here, and I'll see it in ALEKS, so I'll be good. So I want to look at end of here? And let's take a look at this. We've almost done this in the course. So I want to kind of put it in a new light for you and also remind you of this. And there's one thing that we didn't really talk about because I didn't like the way Alex did it. It was too confusing to the students, I felt. So suppose you got a question like this. Describe how the graph of the following function can be obtained from the graph of f of x. So f of x is really right here. So we've looked at what happens if we add or subtract a number next door to the x. We've looked at what happens if we add or subtract a number down the street. What we haven't looked at is what happens to a graph if you multiply by a number in front. So this is a multiplier or a number multiple. So a multiple, you could consider it it could be a multiple if you look at it the right way. But anyway, this 4 out here, what does that do? That's a number multiplier. It's participating in multiplication. So we would just want to look at that, and we want to also remind ourselves about how does each one of these numbers affect the graph of f of x? And in what order do we look at these numbers? And the order question can be answered by, we use PIMDAS. Please excuse my dear Aunt Sally. And that we can answer that way. So, and this is a good review for us anyway. So what happens here with this number in front, this 4, is it can either result in what we call a vertical stretch or a vertical shrink. I really should have the understood word in there of vertical. If there's an understood word right in there before shrink, of vertical. So the number multiplier results in front of the function f. That results in a vertical stretch or shrink. And in this case, we have a 4, and that number 4 is bigger than 1. Our number here, if I plug 4 in here, is bigger than 1, so that results in a vertical stretch. Now, if you were talking about, say, the number 1/2, that number 1/2 in front, 1/2 here instead of 4, if we had a 1/2 here, that 1/2 is between 0 and 1 and would result in a vertical shrink. It works like you think. If you knew that you had a vertical stretch or a vertical shrink, a small number you would think would give you a shrink, and a bigger number would give you a stretch, and that's what happens. So let's take a look here. Let's start. Let's take our function f of x, and we want to create a new function, g of x. And our new function, to get our new function, or to get the graph of our new function, we want to start with f of x, and we want to apply, we want to know how do we get the graph of g of x, where g of x is written out like this: 4 times f of x plus 5 minus 2/3. Well, we use PIMDAS. We're going to start with the graph of f of x, which is already up here from the graph of f of x. PIMDAS, P for parentheses. We want to go inside the parentheses first. We are adding this 5 next door to the x. Does that work like we think or opposite of what we think? Can anybody answer me on that one? Does anybody want to answer that question? Does adding that 5 next door to x work like we would think or opposite of what we think?
Opposite.
Opposite is correct. So instead of going to the right, when we take this x and add 5, instead of going to the right, we're actually going to the left. So we want to take our graph of f of x and shift it left 5 units. And please stop me if you have a question. The next number that we should look at, according to PEMDAS, is we have a choice between multiplication here and subtraction. Please excuse the my stands for multiplication and division. So we are going to do the multiplication next. Our number multiplier in front is 4, which we want to ask ourselves, is that number bigger than 1? Or is it between 0 and 1? And the answer is it's bigger than 1. It fulfills this inequality here, and that means we have a vertical stretch by a factor of 4. And that's usually the way we write it. Factors are multiplied, and this is 4 times f of, and so forth. So we have a vertical stretch. If we had like a 1/3 here, that would be between 0 and 1, and we would have a vertical shrink. So that number works, and that number multiplier works probably like we think. And lastly, we have to deal with this number, minus 2/3. That's that's a number being added or subtracted down the street. So that works like we think. That is a vertical shift. And so we're going to go down, shift down 2/3 of a unit. Any questions on this? This is going to come up somewhere in your final exam process. So I will put this in instructor resources in ALEKS. And I have one more question I want to take a look at here. And then we will talk about matrices. So here's an ALEKS topic, and I got this out of one of the assignments that the 2 5% assignments where the questions you get in ALEKS are going to come from one of those 2 assignments. So and this is finding the roots of a quadratic equation with leading coefficient greater than 1. Solve for u. 5u squared minus 4 equals 9u. This is a quadratic equation because each term is a polynomial, or each term you could consider a polynomial. It's a sum of, you could consider each term really a monomial. A monomial is a polynomial, but let's call them monomials. So this is a monomial because it's a nice number, it's a real number, times a variable u to a nice power. This is a monomial because it's a real number, -4, times u to the 0, u to a nice power. And any number so this is, let's just be clear, this is 4 times 0. No, it's 4 times 1 raised to the 0 power. Don't usually talk about this, but this is 4 times 1 to the 0 power. So you've got a nice, that power of 0 is nice. On this side, you've got 19, which is a nice number. It's a real number. It only has to be a real number, times u to an understood power of 1. So we've got monomials. We've got 3 monomials. I would recommend doing this problem by using the quadratic formula. I wanted to make sure I went over the quadratic formula today. Whether you factor, though, this, which you can factor it, or you use the quadratic formula, in both cases, you need a 0 on one side by its lonesome, by itself. This does not have a 0 on one side yet, so we need to get a 0, no matter which route you take. If you didn't have the middle term, there would be other ways to solve this, but you've got the u term here. So we need to get everything on one side, and we want to keep our leading coefficient positive. Our coefficient in front of the u to the highest power, positive, because it's easier to work with, no matter if you're using the quadratic formula or you're factoring. So we want to move the 19u to this side. So the opposite of addition is subtraction. Let's subtract 19u from both sides. And we want to put our polynomial, our quadratic polynomial, we want to write it in descending power order. We want to write the square term first, 5u squared, and then the u term, minus 19u, and then this minus 4. 19u minus 19u is 0. So we've got our 0 that we need on the right side here. Or it could be on, I mean, you could have it written the other direction too. 0 equals ax squared plus bx plus c. So now I'm not, I wish I had time to take a poll, but what I want to do is show you, you may like to, in this case, I think it's nicer to use a quadratic formula. It's not too bad. So you want to identify your A, B, and C, and that's why one reason why you had to why we have to write this in descending power order, so we don't mix up our numbers with our letters. So our A is the coefficient of the first term, which is 5. Our B is the coefficient of the second term, which is negative 19. Our C is it's actually a coefficient because it's times x to the 0, which is 1. But so we can call it a coefficient technically. So C is negative 4. So we're ready to apply the quadratic formula here. I had to erase x. I'm so used to working x, but you could be given a problem with a different variable in it than x. So I erased it and wrote in u. U equals negative b plus or minus square root of b squared minus 4ac all over 2a. Which reminds me, a student in my class earlier today, she asked me, can you use your notes? And the answer is no. So you might want to create a sheet or two and write down need to knows on it. And I honestly, when I'm studying or I am preparing for a presentation or whatever, I sometimes leave my notes out in the kitchen while I'm cooking dinner. So when I have a free moment or so, I can look at them. So we've got our u here equals negative of b. So that's negative. I copied that down here. B happens to be negative 19, plus or minus square root of b, which is negative 19 squared, minus 4, that's part of the formula, a 5, c negative 4, all multiplied together, all over 2 times a, which is 5. So I worked with this in here. I did that calculation and got 441. Actually, the square root of 441. Let me just take a quick moment here to show you how you can do that on your graphing calculator. You may already know. So I'm going to go to the graphing calculator. And I'm going to clear off my screen. It looks a little bit congested there. And what we're looking for is the square root. If you go over to the first column here, there is the x squared button. If you look above it, there's the square root sign. And that's because square root and the square are related. In some sense, they're inverses of each other. One undoes the other. And that's why they're there together. So if I want to access that little square root sign right here, it's in blue. My second button is in blue. So that's to remind me to click on the second button first, and then the x squared key. That gives me a square root sign. And in there, I want to type 4, 4, 1. And then enter. And that gives me 21. So let's go back. So we got 21 up here. So what do we have now? Negative of a negative is positive 19. Plus or minus 21 over 2 times 5, which is 10. So I'm going to write, we really have 2 possibilities here, just shorthand for 2 possibilities. Let's do each possibility separately. Let's pick only the plus sign first, and then we would get 19 plus 21. I put parentheses around them because I'm going to use the calculator. And there's 2 or more terms here in the numerator, so that's why the reason for the parentheses. So that's 19 plus 21 over this 10, comma. Now we don't pick the plus sign, we pick just the minus sign, and we get 19 minus 21. And again, I put parentheses around them because we're going to use the calculator. Divided by 10. So let's go do each of these on the calculator. 19 plus 21 over 10 and 19 minus 21 over 10 with the parentheses around the numerator. Anytime you have 2 or more numbers represented in numerator or denominator, you need to use parentheses. So let's go back to the graphing calculator. So the first thing I want to do is type in an opening parenthesis, 19 plus 21, closing parenthesis, division symbol, and then 10. 1, 0. And then enter. So we got a 4. Next one. Now I could repeat the entry. Repeating an entry that's at EN, that blue ENTR up here above the enter key. So I don't think you can see that, but it's in blue. And we've talked about this before. You can do second enter. And that puts the same thing on the screen up there. And all I have to do is use this left arrow key, go over the plus sign, and put a minus and click on the minus sign. And now I'm just checking it to make sure that's really what I really want, and hit enter. Now Alex wants fractions. We did not get a fraction, we've got a decimal. So we can use math frac, which means you can have the calculator try to convert it to a fraction for you. And you might want to write this down. And the way we do this and have been doing this is to click on math. We do a math, enter, enter. And there you go, -1/5. So the 2 numbers that we got, 4 and -1/5. 4, comma, negative 1/5. Any questions on this particular topic? This is definitely in one of those 2 assignments, those 2 5% assignments. I wanted to go over it. I know factoring is more challenging for some students than others, so I wanted to make sure I went over this. But you can only use the quadratic formula if you have a quadratic equation. It doesn't work for cubics or other types of functions. So let's now, anybody have any questions? Let me just check the chat for a moment, and I need to get attendance. So let me do that. I think the best place to check the chat is right here. Got a lot going on here. My mind is very full this time of the semester. So I don't see anything in the chat, so I wanted to check that. So let's go back. Let's look at the matrices assignment. So I would encourage you, if you didn't bring your sheet with you today of how to get a 0 and a 1, I would encourage you to copy it down. How to get a 0 and a 1. Because we're going to talk about, especially to get a 0, extensively today. And I think it's very important to understand why this is so wordy. It's so wordy for a reason. So I'll give you a couple minutes to copy that down. I think you'll probably get more out of the one problem we're going to do today if you copy that down, both to get a 0 and to get a 1. So I'll give you a couple minutes. I'll give you until 12:57. And while you're copying that down, let me just get an attendance here. Sorry for the interruption. So especially if you're going into business or want to get into the Walton School of Business, a lot of those students have to take finite math, and you will definitely see, you will use matrices, the process with matrices, to solve linear programming problems. Okay, does anybody need a little more time to copy down how to get a 0 and how to get a 1? Let's go on. Now, let's go back for a moment. This is very important. What's on the left side of these dashed lines is very important. this says the first thing we're going to want to do is get it. That tells us the order to do these in. The first thing we want to do is get a 1 in this upper left-hand corner. That 1 is going to help us to get zeros beneath it. That's why we get the 1 first. You'll see the 1 working in the process, I think, when we look at it in a bit. Once you get the 1 in a column, that 1 helps us get the zeros in that column. In this case, there's 2 zeros beneath that. We want 2 zeros beneath that 1. We then move to the second column, and we want 1s along the diagonal here. And the reasons why we want 1s along the diagonal, because this is really, this right here is really our X column. This is our Y column. This is our Z column. And when you have a 1 here and zeros here, that's going to tell us that we have 1 X. So we have X plus 0 times something, plus 0 times something, which is just 0. So we have X equals whatever this number is. So you get your X coordinate real quickly that way. And by having a 1 here, that's in the Y column. So this will just tell us that Y equals whatever number is here. And the 1 down here tells us this is in the Z column. It tells us Z equals this number. So that's why we have 1s along the diagonal. So we want to start by getting the 1 here, and then we get zeros beneath it. We move along to this column, we first get the 1, then we get the zeros. We move along to this column, we first get the 1, then we get the zeros. So that's how the process works. So let's go take a look at, that is where we stopped in your class. Let's take a look at number 11. In number 11, we want to solve the system by using Gaussian elimination or Gauss-Jordan elimination. We're actually using Gauss-Jordan elimination. If you know Gaussian elimination and you know back substitution, feel free to use that as long as you can write out your work, and that's fine too. So we are given 3 equations. You can put those equations in the matrix in any order you like. I don't want to give it away. Which equation do you think we should put in first? This is equation 1, 2, 3. Which equation do you think we should put in first? And if you could give me a reason for it, that would be great. What do we want in the upper left corner of our matrix? Do we want a 0 or a 1? We want a 1. So there's really an understood one right here. And I just put it in. And there's also an understood 1 right here. So to avoid having to do so many row operations, it's probably a good idea to take one of these rows with the 1 in front of X, or the understood 1 in front of X, here and here. It's probably a good idea to take one of those rows and put it in first. It'll save you from having to do this. You'll have fewer matrices that you need to use in your process. So which one did I pick? I just picked the first one because I didn't have a reason to pick the other. I just picked the first one with the just an X here. It's actually the second row. I picked the second row and I put in the coefficients. So I created a matrix, labeled it row 1, row 2, row 3, because even though I know in my mind those are what the rows are, it helps me make sure I get the answer or the numbers correct. So let's enter this row first, and we just want the coefficients, the numbers. We just want the numbers. So we have 1, -5, 4, and 30. And then I just went down and put in this row 1, 5, -4, 1, 5, -4, and then the -26 on the other side of the dash lines. And last row, -3, 16, -3, 16, 13, -44, 13, -44. Any questions on how I entered that? So we already got that one. That saves us a step because you could potentially have to do 6 different matrices. So anytime you could cross one of them off the list, it's helpful. Now I'm actually doing more because I want to write out the detail so you can see it. But in general, you would have to do 6. I just am, I like to write it out because it's so easy to error. And when I write it out like this, I'm more likely to get it correct. So now what do? We've gotten a 1 where we want it. So the rule is, so what we want to do is in each column, get the 1 first and then the zeros. And then we want to go to the next column, get the 1 first and then the zeros. Then we want to go to the next column, get the 1 first and then get the zeros. So right now we need to get the zeros because we have our 1 that's going to help us get the zeros. And how do we get the row operation? So we want to look at what we need to do to get a 0. And that's the harder of the two. To get a 0 is pretty straightforward. So we want to look at getting a 0 here in this position. So to get a 0, I'm reading off my sheet, take the opposite, which means change the sign. So we want to change the sign on the 1 and keep the 1 as well. We want to change the sign on the number, -1. That's why we have a -1 here. And multiply it times the row with the 1. The row with the 1 is this one. That's row 1. That's the reason for the row 1 here. And add it to the row where you want a 0. Add row where we want a 0. We want a 0 right there. Right there. That's row 2. And this is considered to be the old matrix now. And where's it going to go in the new matrix? We want to just leave it in row 2. We want to put it in row 2 of the new matrix. Then we look at this one. When we do the process again, we want to get a 0 there as well. We can use the same 1 to do so. This 1 here to do so. Here's our number. Take the opposite, change the sign. That would become a +3. Times the row with the 1. The row with the 1 is our 1. Our 1. Add it to the row where you want a 0. You want a 0 in row 3. And we want to put this in row 3 because we have no reason to put it anywhere else. So we're just going to keep it there in row 3 in a sense. So let's perform those row operations where we need to. This is what's changing in the new matrix. We're putting something in row 2, something in row 3. There's no row 1 on this side. That means we just copy over row 1 here. 1, -5, 4, 30. 1, -5, 4, 30. We can only work column by column. We work column by column. Let's look at the column. Let's work in the first column, in the red column here. -1. Oh, before I forget, what do we copy over? We like this one. So let's just copy over this. We like that the 1's already here. We just copy this over. Row 1 doesn't, we're not putting anything in row 1 in the new matrix over here, so that just means you copy it over. 1, -5, 4, 30. 1, -5, 4, 30. Now, this, we are going to use this row operation and put what we get in the old matrix after we do the calculation in row 2 of the new matrix, working column by column. So let's do that. -1, that's right here in row 2. And it's, I know I'm going into row 2 because so I can double check it. So it's -1 times what's in row 1. And that would be a 1. So -1 times a 1 is still -1. Plus what's in row 2. What's in row 2 is a 1. Plus 1. And then while we're here working and focusing on column 1, let's do this one too. 3, copied down, times row 1. Row 1 in this column, in row 1 of this column, we have a 1. Right there. Right there. Plus row 3. Row 3, there's a -3. So plus a -3, that's just a -3. Any questions? They'll get less of this as we go on of things that we need to do. So now let's look in the purple row, purple column. Better got to think of really hard about columns and rows here. In the purple column, negative, let's, first of all, we're only doing the last 2 rows because we copied over the first row. So it would be -1 here times what's in R1 of this column. And that would be -5. So -1 times -5 plus what's in R2 of this column, which is 5, plus 5. And now let's do this one so we can stay in the same column so we're not moving between columns and rows and it might get confusing. So this one is 3. Starts with a 3. 3 times row 1. 3 times row 1, -5. Plus row 3. Row 1, 2, 3, plus 16. And we're done with the second row for now. Move along, or we're done with the second column for now. Sorry, we're done with the second column for now. Now let's move along to the third column. And let's do this row first, this row operation first. So it's, and we are going to, we need to do this one, and we're going to put it in row 2. So it's -1, -1. We're in column number 3. -1 times row 1, 4, plus row 2, -4. Now let's do this. So that would be 3 times what's in row 1, 4, plus what's in row 3, 13. And then we move along to this green column, if you will. And we do the same process, -1. And this is going into the second row. So I'm just double checking to make sure I'm putting things into the correct rows. So we are using this, -1, negative, row 1. Row 1 is 30. Oh, sorry. Yeah, 30, right here, 30. And then plus row 2. 2 is -26. So plus -26. And that goes into row 2. So we're fine. We've done that. We put it in the new row 2. Then we do this. 3 times row 1, 30. Plus row 3, -44. So plus -44 is just -44. And we need to do these calculations. So let's go down. 1, -1 plus 1 is 0. 3 minus 3 is 0. We've got that nice structure beginning to take place that we want. -5, we just copied down. This is negative times negative, which is +5, plus 5 more, which is 10. This is -15 plus 16, which is 1. Copy down this 4. This is -4 plus -4, that's -8. This is 3 times 4, which is 3 times 4, so that would be 4 plus 4, which is 8 plus 4 more is 12, plus 13, which is 25. Over here, we get 30, copy down, -30 minus 26 is -56. 3 times 30 is 90 minus 44 is 46. So we're good. So now we move on. We now look at this matrix. This is now our old matrix that we have here. This is our new. So what we want now, we're looking in the second column, and we want to get a 1 first. But we want 1s along the diagonal, which is this. So this 1 is not on the diagonal, but we can switch rows. We just don't want to destroy this. We want to keep this 1 here for 1. For 2, this structure here, there's 0 in both places. So if we switch this row with this row, we're still going to have 0, 0 here. So what we want to do is switch row. This is row 1, row 2. We want to switch row 2 with row 3. So that's how we write the row operation. So let's switch row 2. In other words, row 2 is going to go to row 3, and row 3 is going to go to row 2. So we want to switch them. We're just copying this over for row 1. All of this just gets copied right there. Now in our new row 2, we want to actually put row 3. So that's 0, 1, 25, 46. 0, 1, 25, 46. And we want to put the old row 2 in row 3 now. That's 0, 10, -8, 0, 10, -8, and -56. And you see we have the same structure that we had in the first column, 1, 0, 0. So we got another 1 for free. That's really cool. So now we've got our 1 in the correct place. We're going to use it to get zeros. How do we get a 0? We change the sign. So the first thing we're going to do is change the sign on this 5, get positive 5. Multiply it times the row with the 1. The row with the 1, this is row 1, row 2. It's row 2. So it's row 2. We want to add it to the row where you want a 0. We want a 0 in right here. We want a 0 in row 1. And we want to put it in the new row 1. We certainly don't want to put it in row 2. We want to keep the 1 there. And we don't want to destroy this structure. So the next one, we want a 0 down here as well. We take the opposite, which is negative 10, multiply it by the row with the 1, which is row 2, and add it to the row where we want the 0. We want the 0 now in row 3. And we're going to put that in the new row 3. So this nice structure gets preserved. So all I have to do is copy this first column will be the same first column all the way. 1, 0, 0, 1, 0, 0. I just copy it down like that. So I'm really only having to look at this part of the matrix now. This part over here. These last 3 columns. So let's apply the row operations. Now, what changes? So we're going to put something in the new row 1 and in the new row 3. So that means this is going to change and this is going to change. The 1 in the middle doesn't change, so let's just copy it over. 0, 1, 25, 46. 0, 1, 25, 46. So now let's apply these row operations. Let's take 5 times row 2. Got to work in the same column. What's in row 2 here is a 1. So 5 times 1 plus row 1. Row 1, there's a negative 5. And we need to, and let's go down and do this one. Negative 10 times row 2. Row 2 here, row 1, row 2 has a 1. You can see how that 1's helping us get a 0. Plus, what's in row 3? What's in row 3 here is a 10. So that's how this 1 is used to get a 0. If we had a 0 there, it wouldn't work. So we get negative 10 times 1, which is negative 10 plus 10, which is 0. So that's how we get the zeros. Any questions? We just did those. We just did the row operations that we needed to do for column 2. Let's move along to column 3. Apply these row operations. So 5 times row 2. 1, 2, 25. Plus row 1. Row 1 is 4. And then let's do this row operation while we are working in column 3. Negative 10 times row 2. 1, 2, 25. Plus row 3. Plus row 3, 1, 2, 3. Plus negative 8. Plus negative 8 is just minus 8. And lastly, on this, we need to look at these constants over here on the other side of the dashed lines. 5 times row 2, 1, 2, 46. Plus row 1, 30. And down, we need to do this one. Negative 10 times row 2. So negative 10, row 2, 46 plus row 3. 1, 2, 3, that's minus 56. And we just need to calculate what those are. So let me see, I think, yeah, I wrote it, I just copied it down like exactly like that. I copied down exactly what we had at the bottom of the previous page is exactly what's at the top of this page. So let's take a look. So we just need to clean everything up. 5 times 1 is 5 plus a negative 5. That's 5 minus 5, which is 0. And I just copied this down. Then a 1. Negative 10 plus 10, 0. Moving along to this column right here. So 5 times 25. 5 times 25 plus 4 is 129. Copy down this 25. Do this calculation. Negative 10. Negative 10 times 25 minus 8. And I get negative 258. Move along. Do 46 plus 30. Get 260. Copy the 46 down. And lastly, do negative 10 times 46 minus 56. And I get negative 516. So we are getting there. And really, when you start your new matrix, you can automatically copy down this structure, 1, 0, 0, 0, 1, 0. And it's getting to be less what we need to do all the time. So what do we need to do next? Can anybody tell me what we need to do next? Does anybody want to tell me what we do next? We always need to get a 1 first in each column. So we want a 1 here, where this negative 258 is. How do we get a 1? Take the row where you want a 1. We want a 1 in row 1, 2, 3, row 3. And multiply it by the reciprocal. So this is really negative. This is really negative 258. I'll just write it off to the side here in orange. Over 1. The reciprocal means you just flip over the fraction. That is, and that's in my notes when I said, when I wrote down to get a 1, what you do. So you flip over this fraction, you would get negative 1 over 258. And I just put the negative sign in the denominator. It doesn't matter where you put it. So I took this, flipped this over, and got 1 over negative 258, if you want to be precise. That's fine. So you could look at this as you take row 3 and you divide it by negative 258, and you put it in the new row 3. So that's really all we need to do there. Not a lot to be done there. All we're changing in this step is row 3. In the new matrix, all that's going to change is row 3. So we copy row 1 and 2 over. 1, 0, 1, 29, 260. 0, 1, 25, 46. In addition, we can copy over this nice structure, these zeros here. So we don't have much left to do. So what do we want to do with this row operation? We want to take each element that we have to do something with in row 3 and divide it by negative 258. If we take this negative 258, and for a moment, maybe I should get rid of this because I think this might be confusing you, and I hope it's not. But of course, you know, when you're first learning something, when I'm first learning something too, I get confused sometimes. So yeah, there's too many things to figure out and see all the connections, right? So there. So what we want to do here, we want to take this element in row 3 and divide it by negative 258. So if I divide this by negative 258, we're dividing by exactly the same number. So we're going to get just the number 1. We get a 1 here. And if we take negative 516 and divide it by, so this one, so we want to take negative 516, this guy, and I think I'll write it out here. I hope I can fit it in. Negative 516. And what does this say to do? We took negative 516 because it's in row 3, and we want to divide it by negative 258. Negative over a negative is a positive. 516 divided by 258 is 2. That's where this 2 came from. Any questions? So now we're down to this. We're getting very close to the end here. So what we have last to do, we've got our 1s along the diagonal like we need to get 0s here above this 1. So you get the 1 first, 0s elsewhere in the column. Get the 1 first, 0s elsewhere in the column. 1 first, 0s elsewhere in the column. You want to make sure the 1s are along the diagonal because that will give you your x equals, your y equals, and your z equals. So we want to get a 0 here. So to get a 0, we change the sign, so we get negative 129. And multiply it times the row with the 1. The row with the 1 is row 1, 2, 3. This is row 3 down here. And add it to the row where you want a 0. You want a 0 right here in row 1. And we want to put that in row 1 of the new matrix. That's what that is saying. Sometimes you might see Alex writing the rows over here, but it still means the same as long as you are aware of what your old matrix and your new matrix are. So let's do this one. We want a 0 here, so we take the opposite of the number, negative 25, times the row with a 1 in it, which is row 3. And then add it to the row where we want the 0, which is we want a 0 right here in row 2. And so we get negative 25 times the row with the 1 in it, which is our 3, plus the row where we want a 0, which is row 2. And we're going to put that in the new row 2. And I didn't write that out as detailed as I should have. So let's do a little calculation here. What do we have to calculate is what we need to really think about. So we already know that this is what we want, this is what we want. Let's look up here. We already know this is what we want, this is what we want. This 1 is what we want. We're only changing row 1 and row 2 in the new matrix. And this structure we like because it has the ones and the zeros that we like. So the only numbers that we really need to be concerned with at this point are, let me get a different color so it doesn't get so congested. And I will explain this in more detail in a moment. The only ones we need to be concerned with are these guys right here. Those are the only ones we need to be concerned with. So let me tell you why that is. Because we have this 1 in this column with zeros elsewhere. We have 1 in this column with zeros elsewhere. We already have a 1 in this column. And this is the X column. Let me get a different color. Let's maybe do blue. This is the X column. This is the, I got to finish the X column, X. This is the Y. This is the Z. And this is the constant on this side. How do I know I'm done? I know I'm done here because I've got the structure I like. How do I know that I'm done with this 1 and this 2? How do I know whether I need to go any further or not? Because what do we have as in our last row? We have 0 x's, which means we have no x's, plus 0 y's, which means we have no y's. We have 1 z, which means we have z, and this means equals. This means equals right here. So we have z equals 2. So we have found our z. So we're done with that. So we don't need to do anything there. We just need to work with these guys. So we copied this down, copied this down, copied the 1 and the 2 down. Also, right here, this says that the only rows that are changing in the new matrix are 1 and 2. That is another clue that we are only changing the 1 and 2 here. And this structure is preserved, so we don't need to worry about the 1s and the 0s. So let's look at this. Let's do these by hand. I don't think it's as bad as it necessarily looks, but we don't have too many of them to do. So let's start with our row operation here. Negative 129 and negative 129 times row 3. So let me write this down. So we're in this column. We have to keep in that column. So negative 129 times row 3. 1, 2, 3. We have a 1. Plus what's in row 1. What's in row 1 is 129. And what is that equal to? It's equal to 0. Gives us 0 right there. Because it went into what we did is going into row 1. Right there. Now let's do this row operation. Negative 25 times row 3. Oh, I forgot to do it on the, yeah, we'll go over there and do those too. So we're working in the same column though. Let's keep working in this column. So we get negative 25 times row 3. Plus row 2. Row 2, we have a 25. And negative 25 plus 25 is 0. So that's why we get a 0 here as well. So now we want to move along to these guys. We haven't done these guys yet in the last column here. So we want to take negative 129 from up here. Negative 129. Negative 129. Looking right here, times R3. Row 3 here, we have a 2. Plus row 1, 260. And what's that equal to? So let me just do that on my calculator. So we've got negative 129 times 2 plus 260. And I get 2. And what do? We were doing this, which goes into row 1. So that's where this 2 came from. We have one more row operation to do to finish up. That is this one, negative 25 times row 3. That's a 2. Plus row 2. That's 46. And back to the calculator. And that's what's going to go in row 2. And it should be equal to negative 4. So let me just check. Negative 25 times 2 plus 46. I do indeed get negative 4. So let me just write that down, negative 4. So it's complete. So let's look at this. So what is this really saying? This is really saying let's look at this row right here. I'm not exactly sure how that little dot got there, but sometimes those, oh gosh, I don't want to delete that. I really don't. I'll just leave that little dot there. We'll just ignore that dot. So what are we really looking at here? Let's look at it row. Now we're going to look at the rows. So this is 1 times x, which is x, plus 0 times y, which is 0. X plus 0 is x. Plus 0. X plus 0 is still x, equals 2. So x, this first coordinate here is x, and it is equal to 2. Let's look at the second row. 0x, that means we have no x's, so we have nothing. Plus 1 times y, which is y. plus 0z is 0. 0 times z is 0. So we just have y equals -4. That's why the -4 is here. And going to the third row here, we have no x's, no y's. We have 1z, 1 times z is z, equals 2. And that's the reason why the 2 is in the z position. This is x, y, z in alphabetical order. For some reason, Alex uses braces around it. I'm not exactly sure. I spent a lot of my graduate school career studying matrices, so I'm not sure. I really haven't seen it like that too often, but that's how they chose to do it. Any questions on this problem? So that is the answer. I do have a few minutes left, and I think it would be wise if we talked about how we set up this problem. We don't have time to do it, but how do we set it up? So Amanda stayed in 3 different cities: Washington, D.C., Atlanta, Georgia, and Dallas, Texas. Interesting. Those 3 places seem to be in the news currently, for a total of 11 nights. She spent twice as many nights in Dallas as she did in Washington. The total cost for 11 nights, excluding tax, was $1,940. Determine the number of nights that she spent in each city. So they're giving us a cost per night table for each one of the cities. The way Alex does this is when I looked up Alex's explanation, and you've got that in your assignment, you've got some learning aids there. They let W be Washington, A for Atlanta, D for Dallas. And you see they've gotten 3 equations. And so we need to look at why we get the equations that we do. If you're looking here, notice they took W plus A plus D equals 11. And why did they do that? Because if we look at the number of nights, let's let W be the number of nights she spent in Washington, and A be the number of nights she spent in Atlanta, and D be the number of nights she spent in Dallas. And that's what we're trying to find here at the end of the day. Determine the number of nights she spent in each city. So we're calling those our X. Well, actually, no, we're calling those our W, our A, and our D. So W, the number of nights in Washington, plus the number of nights A in Atlanta, plus the number of nights D in Dallas, equals what? Equals 11. 11. So those W plus A plus D equals 11. Well, we'll save this one for last. This is perhaps the tricky one. If you notice, they give us costs per night. So we know we're going to use that. So let's say we stayed 3 nights in Washington. She stayed 3 nights in Washington. So that would be 200 plus 200 plus 200, which would be 600. So if this were 3, the number of nights, 3 times 200 would give us 600. So it makes sense to take the cost per night and multiply it by the number of nights to get her total bill for staying in Washington. So we take 200 times W. 200 times W. Keeping up with that pattern, we would then take 100 times Atlanta, we're letting be A, 100 times A. Keeping up with that pattern, here's 100 times A. What about Dallas? 190 times D plus 190 times D. And how much does that total bill cost? Let's see, $1,940. I wanted to pick a problem you could relate to. Okay, so we have one more statement that we have not used yet. She spent twice as many nights in Dallas as she did in Washington. Twice as many nights in Dallas as she did in Washington. So let's say she spent 5 nights in Washington. If you take 5 and multiply it by 2, you get 10. That means she would spend twice as many nights in Dallas as she did Washington. Twice as many nights. Makes sense. D equals 2 times W. Question is, which side do you put the 2 with? We'll come up with a little example and test it out. So we don't want to write it like this for Alex because we want all our variables on the same side. Or sorry, we don't want to write it like this for matrices. We want all our variables on the same side and a number on to the right side of the dash lines. So if we need to move either the W to this side or the D to this side, one or the other, doesn't really matter. So let's subtract D from both sides. That will leave us with 0 on this side equals 2W minus D. And you can turn it around as write it the 2W minus D on this side and the 0 on that side. And then you just put them in. You put the coefficients in. So now we're going to have a W, an A, and a D column instead of X, Y, Z. And you just put everything in. So this one goes in, 1 in front of W, 1 in front of A because the W, A, and D are up here. And 1 in front, so 1 in front of each of these variables, or 1 below each of these variables. So for W, A, and D, the coefficients in front are 1, 1, 1 equals 11. Over here, let's do this one next. The coefficients of W, A, and D are 200 in the W for the W column. Doesn't matter which order you do these in. 100 for the A column. 190 for the D column. Equals 1,940 for this column. Over here, 2 in the W column. That's the coefficient of W. We do not have any A's, so we put a 0 placeholder. And we have negative 1D. So we put negative 1 here. Equals 0 on the other side. So this is a great place to leave it. So I'm going to come back up to you all. I think from here you just work it as we worked the last problem. So let me take attendance again just in case. And I just want to commend all of you for all of your hard work. I've had conversations with 2 students recently, one of which works in a nursing home testing patients for COVID, who said, I know that this is what I'm supposed to be doing, working in a nursing home. Even though it puts me at risk for COVID, I know this is what I am supposed to be doing. I had a student that asked me to write a recommendation for him because he's trying to get into West Point. And I wrote a recommendation for him. We had a conference just so I could get to know him better. And I asked him, do you know with every fiber of your being that this is what you're meant to do, to go into the military? And he said, yes, I do. So what I'm saying is my wish for all of you is that you either already know what you are supposed to be doing in life, that you will that you're supposed to be doing with every fiber of your being, or that you soon find out. And it's okay if you don't know. I did not know until I was a senior in college what I wanted to do, which was go to graduate school in math. And when I was in graduate school in math, I discovered computers. So I love both of them, and they're who I'm meant to be. And I have that wish for all of you because I really do care and love each and every one of you. So I want to say good luck on the final exam, the both parts of it. And if you need or have any questions, and we can find an agreeable time, a time that works for both of us, I will be glad to meet with you over the weekend if you need some help. So I just want to say goodbye to you all and wish you all the best in life. And if I can do anything for you at all, let me know. So I want you to take care. And if you want to talk to me now, just stick around. So bye for now. Hopefully I'll see you around in WAC when the pandemic is over.
Oh, that was beautiful.
Oh, thank you, Courtney. Bye for now. Take care.
Bye. Thank you.
You're welcome, Olivia.
Bye. Thank you.
You're welcome, Luke. Feel free to leave the conference or stick around if you would like.
Thank you, Miss Bear.
You're welcome.
Okay, so I have a question.
Sure.
Just because I noticed that like all the assignments are open now, right? Is that right?
I believe so. This is the first time Alex has ever done this. So I believe that is correct.
So like if they get done, like do I just send you a picture?
Of the assignments.
Okay, because I had did that, and I don't know if you got them or not because none of the grades in the grade book changed.
So where did you send it?
Oh my gosh, who knows? Probably the wrong place, or probably the wrong
I don't
email.
know about that. I just get so many emails all the time.
Right.
Sometimes it might just get overlooked or something.
Right.
It may not have gone through. Who knows? It may not be either one of our faults. So
Right. Well, and you wanted me to make sure that my name was in the top right.
yes, yeah. I think we could forego that because I've given up on asking for that because
Yeah.
you're sending it from your account.
Yeah.
Yeah. So you it's not as if you can get in anybody else's account.
No, you're right.
So.
So like, when's the latest you'll accept those, or like?
Well, I would say certainly by Thursday of next week.
Oh, I'll do that before. I've been working. Like that's my goal is to get all those done. And
yeah, I understand, but I would make sure you're. To me, I think it's a higher priority that you do those.
Oh yeah, I finished the Gauss Jordan. I actually remember that from last year, and
that's amazing. Good.
Well, yeah, it's actually very lucky because I remember I did not have a good time with it then.
But you got it down now.
Oh yeah, I got it down. Like I did like 3 or 4 in a row, and I was like, okay. And I started on the reviews.
Wow, I'm so proud of you for you're really stepping up.
I know. Like, oh my God, like so much different from last time.
So did you use my lab math or my math lab?
Yeah, I did last year.
What do you think about the differences in the software?
I definitely like this software better because they, I mean, it's more accessible and you have, choices of like where to find information, and whatnot.
Yes, and I hear that from so many other students, and I've been trying to encourage other faculty to use it because I've become a pretty big advocate for it. The Alex folks actually paid for me to go to Chicago, not this past summer, but the summer before. And one faculty member was going to do it, but then COVID, you can't expect.
Yeah, that's definitely put, I guess, a strain on everybody.
Right. And so she wasn't, and I don't blame her because we had to go online so fast in the spring.
Yeah.
Yes. Oh, well, it's a pleasure to have you. So yeah, yes, 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 yes.
Okay, okay. All
I,
right, well, I'll definitely get at least
I,
get a picture of them like this weekend and then send them to you.
yes, yes,
Okay.
yes. And that's so good because I, the Alex folks asked me to comment on something yesterday, to give them advice yesterday. And I'm like, I made sure I wrote about about the new, what they're doing with the objectives now. And I actually wrote, please have the grades automatically update.
All right. Yeah, I bet that's a mess.
Yeah, I bet it is a mess too, because
Uh,
it's an artificial intelligence system, which makes
yeah.
it more complicated to change. Yeah.
Well,
Okay,
it's
well,
been a pleasure, Miss Bear, and
thank you so much. You're so sweet.
thank
I
you.
know. How's your daughter?
Well, you knew she was getting her tonsils and her
Yeah,
adenoids.
noise.
Yeah,
Yes.
she's good. She's recovered very well. She wakes up kind of raspy, but I asked her if she breathes better, sleeps better, and she said yeah. So,
Oh, I bet that's so different for her. I know how that is. I have bad environmental allergies. I lost my breath like summer, not this summer, but the summer before, and I was struggling to breathe in the middle of the night. And I'm like, oh, thank God that I tend to be how do I read, like I can't think of the word I'm looking for, but I'm generally calm.
cautious.
Yeah,
You're
calm. And
Yeah.
so I'm like, let me go over and drink a bottle of water and see, or drink some water and see if that'll get me to recover. And it did. But
Yeah. My son has really bad allergies. He does shots like every week.
me too.
Uh,
I go to the local allergist every single week. I actually just switched to every 2 weeks. But yeah, I go every couple of weeks now to get shots
yeah,
in
it's like
both my arms. Yeah.
that's crazy. Well, I see other people are on here still, so I will give somebody else a
Yes,
turn.
and I think they may have just yes. Thank you so much. I'm
You're
so
welcome.
proud
Thank
of
you so much.
I want to just tell you one quick story. I had a student ask me for a recommendation. He took Alex from me back in 2018. He didn't even get a 50% in the class. He took me again in the spring. He got over 100% because he really stepped up. I'm like, I'm so proud of you, Courtney.
Thank you.
I really am. Yeah, that's so good. So yeah, enjoy your daughter. I have two daughters myself. They're 9 and
Oh,
15.
yeah. Oh my gosh.
I was
Okay.
almost in tears when you told me about your daughter. So
Yeah.
see you
Yeah.
later. Maybe I'll see you
Oh,
again.
of course. Thank you.
Bye.
Bye.
Guillermo, Leah, do you need anything? I'm gonna leave the conference now.